Alrighty, so now with this one, we have to take that 2 through to everything, because remember, you got to do parentheses first. So that becomes 2 squared, right? Take it through. And 2/3 squared becomes 4/3. And that 2, when I bring it through, that becomes 2/2. So notice how I got a 2 squared. That's a 4/3, and that's 2/2. So when doing this, let's just simplify everything, right, by multiplying it through. 2 squared is 4, so 4 times 3, that's how I got 12. I have x to the 4/3 and x to the -5/6. So what I did was I found a common denominator first, and then I added. So to do that, all right, in order to do that, I multiplied this by 2 on both the top and the bottom. That's why I got an 8/6. So I have 4 times 2 is 8. 3 times 2 is 6. I did that, so I have a common denominator now to add those. Over here, 2/2, that is a y, and y to the 1/3. Okay, so now we can simplify the top here. 8/6 plus -5/6, because what do you do when you're multiplying those x's? You add the exponents. So it actually gives you 3/6. Well, 3/6 simplifies to 1/2. So I have 12x to the half, and I have y and a y to the 1/3. Now, keep this in mind, okay? I need to get rid of this fraction here on the bottom. It's a 1/3. So what can I multiply to make it a whole? So y to the something power on both the top and the bottom to make that number whole. So it's a 1/3. So 1/3 plus something will make a whole. That something happens to be 2/3. So I'm going to multiply both the top and the bottom by y to the 2/3. So 1/3 and 2/3 gives you a whole on the bottom. And the reason why I have 2 y's there is this y was already down here, and now this gave me another whole y, and that's the top. So I have a y squared on the bottom, but here's what we also know. I can't put these under the same root, because this is a half and this is a 2/3. So somehow I have to make them have the same root. So in order for them to have the same root, to put them together under the same root sign, I need to find common denominators for both of these. So I rewrote this to the 6th power, right? Because what do they both have in common? The 6th. You can't combine them together. You want one root as your final answer, not 2 separate roots. This would be a square root. This would be a cubed root. And you can't have that. You want one root on the bottom. So to get one root there on the bottom, that's what we're doing here. So I multiplied this by 3. So that's why it's 3/6. I multiplied this by 2 to get 4/6. And now they have the same root. So now when I do this, I could take a 6th root out of both of them, and I have an x cubed. Remember, the numerators stay on the inside, the denominator goes on the outside. So that's why it's x cubed, and y to the 4th with that 6th root on the outside, and y times y is y squared.
Gosh, I'm getting sick. You smell like after-shaven taco meat.
Yes, I do.
Okay, so it's combining radicals as easy as pie, just as easy as this guy who flips off the stairs and lands on his skateboard. Just like any other fraction, you want to combine the denominators, it's not a problem. So let's take a look.
The arsonist has oddly shaped feet.
So the cubed root of a and the square root of a. Well, when we write that as fractions, right, we get a to the 1/3 and a to the 1/2. I can't combine them together unless they have the same base, because I want them to be under one root together. So the only root that they could combine together would be the 6th power. So I'm going to add them together, and when you add fractions together, very simply put, you have to have the same denominator. So to find the same denominator, I'm going to multiply that one by 2, multiply that side by 3. So I actually have a to the 2/6 plus 3/6, which gives me a to the 5/6. And when I rewrite it, remember, the denominator That's your root, so it would be the 6th root, and the numerator is your exponent underneath, so it's the 6th root of a to the 5th. So in this one, rewrite your roots, so that will be a to the 1/4 power and a to the 2/3. Now once again, we can subtract them, but here's the problem. When we subtract them, right, the denominators aren't the same, so I need to make the denominators the same first. So to me, what jumps out is a 12. So if I multiply this side by 3's, multiply this side by 4's, I'll get 3 over 12 and 8 over 12. So when I do that, 3 minus 8, I get a to the negative 5/12. And because it's negative, I have to move that to the denominator, so I get 1 over a to the 5/12. But we run into another problem. Not only are we not allowed to have negatives, which we got rid of, thank goodness, but I can't have a fraction in the denominator with an exponent. So what can I multiply the top and the bottom by to make a whole? I have 5/12. So 5/12 plus what gives me a whole? 7/12. So I'm going to multiply by a to the 7/12 on the top and the bottom. So by doing so, I end up getting a to the 7/12 on top and 1 whole a now on the bottom, because that adds together. And now I can rewrite this as a root. So I get the 12th root of a to the 7th over a.
Hello? Hello? Anybody home?
Okie dokie.
So there's your homework.
Son, I'd like you to step away from this back there.
Page 33 through 35, 10 through 66, even.
In this quadrant.
Please make sure you work with someone else on these. These can get crazy. There are a lot of steps to simplifying. The big thing to remember is the numbers. Simplifying those numbers. I think most kids remember to simplify. They remember the rules to simplifying the variables. They remember how you can't have negatives anywhere in an exponent. They remember how you can't have fractions in the denominator in the exponents. Okay, more and less people remember that, but they have a hard time with the numbers. If you have the cube root of a number, you got to see if you can simplify that down. If you have the square root of a number, you got to see if you can simplify that down. Okay, so don't forget to take a look at those numbers and see if you can actually simplify them. If you have any other questions or concerns, please let me know.